y equals e to the x cos x. So let's draw in the cosine e to the x function here as a guide, because cos varies between 1 and minus 1, doesn't it? So it's going to go up to touch these. Touch these values. And then it shoots down here. Tends to 0. And let's draw in the minus of this. And it goes through minus 1. And then that shoots negative as well. Like so. Now we'll do pi and 2 pi, I think. So let's do pi here, and let's do 2 pi here. Now let's draw the cosine function. This is the value 1, isn't it, when e to the 0 is 1. So we can put in an asymptote here, a maximum value for cosine, so that might be helpful. So there's 1, there's minus 1. So we can just quickly sketch the cosine function now, and then we should be able to draw the product. So the cosine 0 is 1, cosine 90 is 0, then minus 1, then 0, then 1, isn't it? So here's the cosine function, and then it swings down and up and down. And then on the other side, we've got minus pi here, and minus 2 pi. And it does the same the other side, so it goes round to 0. So it goes round to 0 halfway, minus pi over 2, then it goes round to minus 1, then it goes round to 0 at minus 3 pi over 2, and then back up to 1 at minus 2 pi. That's the cosine function. Here's e to the x. Now we need to do the product. Well, cos is 1 here. So whenever cosine reaches 1 or minus 1, it's going to touch here. So let's mark those points. So it's going to touch this value here. It's going to touch this value here. When it's 0, it's going to go through 0, isn't it? And then it's 0 here. And then it would be 1 here. Okay, and then on the other side, it's going to be 0 here. Then it's going to go here to that value there. Then it's going to go through 0. And then so it's really flattening it out really quickly. Now, as it comes around, the question is, it would look at first instance, so this would be the maximum here. But you see the product of e to the x cos x. E to the x is increasing so much more quickly than cos x is decreasing. So that goes through this point, and cosine, this constituent, is a maximum. It looks like the maximum is going to be just after. So why don't we look at where the maximums are in this? So here, just to be sure, y dash then is equal to u times the v dx. Cosine goes to minus sine, plus v, that's cosine, times du is e to the x. Let it equal 0. That tells us then that the e to the x can be divided out, and we get sine x equals cosine x. Move the sine over. Sine x equals cosine x. Divide by sine both sides, or divide by cosine both sides, and that will tell us that tan x equals 1, won't it? So x is pi over 4, plus or minus n pi is the solution for the tangent. So, what have we got here then? Pi over 4 is this is pi over 2, so halfway between it is the maximum. So the curve is going to swing up here, go through that point there, but then not max out until it gets just above it. So I'm going to try and draw it now. So it's just a little bit after pi over 4, after these low points, so here. So we're going to come a maximum here and then come to that point. Then we're going to come down, come to a maximum and turn up to here. Then go back up to 0 to a maximum. Then turn down to here. Then through 0. And then go along here. Up and down here, it oscillates through there. So that looks like the curve. Let's have a go at sketching it then. I've done it here. I'm going to do from -2, say. up to say 3. Let's have a look at that. See if we can get something from the curve. Yeah, let's do it to say 5, shall we? See if we can get an undulation in the curve. There we go. And that's what we had in our curve. Should we do it to 6? We can see it's oscillating. See the maximum here? Then it swings back down and goes underneath. It comes back down here like we've got here, up just after pi is the minimum. So just after pi, and then it goes back up and swings up to a maximum.